Good day everyone, welcome to Electrifying Circuits with Craft. In today's video, we're tackling the 2024 past paper, specifically focusing on question 3. We'll explore the different types of power transformers, learn how to perform transformers, calculations using essential formulas, and examine power quantities and the power triangle. Whether you're prepping for your exams or looking to deepen your understanding of electrical engineering concepts, this video has you covered. So let's get started on electrifying our knowledge. And don't forget to subscribe, like, share, comment, and hit the notification bell for more electrifying content. So question 1 has asked us to state two types of power transformers that are used on electrical grid from the generation to transmission and distribution of electricity. So the first one is known as a step-up transformer. Now a step-up transformer is used to increase the voltage from the generation level to a higher voltage level for efficient transmission over long distances. The second one is a step-down transformer, and this is used to decrease the voltage from a high transmission level to lower levels suitable for distribution and end user consumption, such as you and I. Now part 2 says that we are to sketch and label one of the power transformers stated above, whether it is a step up or a step down transformer. Now in the step up transformer, the primary side, which is generally the incoming side, has a lower voltage, right? So that's the side where the lower voltage is applied. So it has less turns than that of the secondary. So all you would be required to do is to draw the two windings, such as a diagram looking like this or like this, and then label the primary side, secondary side, right? That would suffice. Now the other one is so they ask you to label one, but I'm showing you both. So the second one would be a step-down transformer. Now the primary side would have more turns than the secondary side. The other part 3 says that you are to calculate the current flowing through the voltage source of a transformer if the current flowing to the load is 10 amps with a transformer ratio of 63.5 to 1. So that's a ratio, meaning that every 63.5 turn on the primary, you have 1 turn on the secondary. To calculate the current flowing from the voltage source, which is the primary current of a transformer, given the load current, which is the secondary current, and the transformer ratio, we can use the following relationship. IS over IP equals NP over NS. Alright, so where IP is a primary current, IS is the secondary current, which is flowing from the load, NP is the number of turns on the primary, and NS the number of turns in the secondary. Now given that transformer ratio of 63.5 to 1, it means that the number of turns on the primary will be 63.5 and the number of turns on the secondary will be 1. We also know that the secondary current is 10 amps. So in order for us to come up with that formula and to make IP the subject, we rearrange the formula. If we use IP, and of course if you look at different documentations, you'll see different formulas being used, but they all work out to be the same. Alright, so some you will see NP over NS is equal to IS over IP. It will work out the same. So we're trying to make IP the subject. Alright, so it will be IP multiplied by NP. If you cross multiply, so IP is equal to NP, which is equal to IS times NS. So we want to make IP the subject. In order to get IP by itself, we need to get rid of NP. And to do that, we have to divide. Now anything you do to one side, you also have to do to the other side. So IP, having removed those, is now equal to IS times NS over NP. Right, and that's pretty much how we got to this stage. Alright, so since the ratio is 63.5 to 1, we can now write that 1 over NP, 1 over 63.5, right, and we substitute the values, which is what we had started here. So we now have IP is equal to 10 amps, which is what IS is, over 1 divided by 63.5. Now, when we cross multiply, if we multiply the 10 times 1, that's how we'll get the 10 over 63.5. So when we divide the 10 into 63.5, we'll get 0.1575 amps. Right? So whether you use the formula NP over NS is equal to IS over IP, your answer will work out to be the same. The part B says that to state a metric unit of measurement for the following quantities. True power. So for true power, the unit is watt. For reactive power, is volt ampere reactive. So it's VAR. And for apparent power, it's volt ampere. So there's a triangle here with some formulas that can be very beneficial to you. Part 2 of B says that we have to identify one of the power quantities that you would have mentioned in B that is used to determine power factor. So power factor, in order for you to calculate power factor, it is active power, which are true power, divided by the apparent power. Right? So we could use any one of these based on what the question asks. So the question asks to identify one power quantity that is used to determine power factor. So we could use the true power or we could use the apparent power. Right? Now the other question, which is part 3, asks us to draw and label a power triangle to represent all 3 power quantities. Now one of the things that we need to look at when we are doing exam, or we need to pay attention to. Now, if you did not know what those power triangles or what the power triangle consists of, the question would have given you in part A, when it asks you to state the unit of measurement for the power quantities. So if you identify the true power, reactive power, and apparent power, then it means that when you get to part 3, which asks you to draw and label the power triangle, then you wouldn't have, well, you should not have much difficulties where that is concerned. And the good thing about it is, even if you were not able to label the entire diagram, if you even drew the triangle and draw it correctly, then you would have gotten some of the marks. Alright, so here we have the hypotenuse side, or the longer side, where we have that being labeled as the apparent power, where we have the reactive power, and the real power, or what we call the true power. Alright, so part C says that we're to calculate the output true power and the corresponding reactive power of a transformer with a rated output of 200 kilounits at a power factor of 0.8. Now, when we look at what is given, we have the apparent power, which is 200 kilovolt amperes, and we have a power factor of 0.8. Now, in order for us to find the true power, remember that the the triangle has the three sides, right? So it has the apparent power, it has the true power, it has the reactive power. Now, one of the things that you would also want to remember is that when you are finding power factor, good, so power factor is the true power over apparent power. Power factor is equal to true power over apparent power, right? Or if you wanted to write P over S, right? So you could say that would be P and the apparent power would be S, right? In this case, we are given the power factor, so we are given the power factor and we are given the apparent power. So we need to find true power. So we transpose in order to find that. So if you cross multiply, you'll have the power factor multiplied by the apparent power. And that's what we did here. Right? So S times the power factor, which is 200 multiplied by 0.8, and we would have gotten 160 kilowatts. Now part C now asks us to remember that it has asked us to also find the reactive power. Now, in order for us to find the reactive power, in order for us to find the apparent power, it would be the apparent power is equal to the real power plus the reactive power. Right, and we'll square those. So we want to find the reactive power. So we'll transpose. So Q is equal to S squared minus P squared. Right, and already we know that the real power, the apparent power is 200, and we calculated the true power, which is 160. So we square those, subtract it, and what is left from that, you would have found the root for it. Right, so therefore the output of the true power would be 160 based on our calculation before, and then the reactive power is now 120 VAR. Alright. Now these questions would have just taken some amount of thinking and putting back what you would have learned in class in practice. Now I know that sometimes based on how nervous you are and looking at all these figures oftentimes throw you off. Well, you need to read the questions carefully and look, because in most exams, one question will answer another. Alright? So we would have looked at transformers, the different type of power transformers that are used for power distribution, generation and distribution. We would have looked at how to calculate the primary current, since we were given the secondary current. And then we had to look at the power triangle and their relationships. That's it for today's comprehensive look at power transformers, transformer calculations, power quantities, and the power triangle from the 2024 past paper question 3. I hope you found this video helpful in breaking down these crucial concepts. So if you enjoyed the content, please give it a thumbs up, subscribe to Electrifying Circuits with Craft, and hit the notification bell so you don't miss any future videos. Also, feel free to share this video, leave a comment below, and let me know what topics you'd like me to cover next. Until next time, keep exploring and keep electrifying your circuits. Bye!